Hi, this video is on chapter 4, section 10, multiplication and division equations. It's similar to what we learned in lesson 9. In fact, I want to go over one thing about lesson 9 that I didn't mention. If you have an equation that would have a subtraction of a negative number equal to any other number, let's take 8. You can opt to do the keep, change, and make this add positive 4, which is a little simpler to get, probably, and then you can just subtract 4 from both sides to solve that. Likewise, another thing you could do, if you have this kind of situation, so it's adding negative 4, d plus negative 4 equals 8, I can either subtract negative 4 from both sides, I can keep the same operation with the opposite number. Either way, I get a zero pair, and I meet the goal of isolating the variable, which is one of the big ideas in solving equations, to isolate the variable, get it all by itself on one side. Whatever I do to one side, I have to do the other. So d would equal 12 in this case. So just as a quick review of how you can work with some addition and subtraction equations. The topic for today, multiplication and division equations. The guidelines are to simplify both sides, do all the arithmetic you can do on the left and right side before you start using a property of equality. When you're having to undo a multiplication or division, it often makes things easier if you change all the mixed numbers to improper fractions after you've done the simplifying. And then you choose either the multiplication or the division property of equality to isolate the variable. And sometimes you could use either one of the two, and you just use the one that may be simplest in that case. We're going to do two example problems, one from page 98 and one from page 99. The problem is presented in the upper half of page 98 is 2/5 times a number equals 9.5. So what I would do, see, is there any arithmetic I can do? Yep, it's all done. This is one term on the left, another term on the right. So I'm going to change this to an improper fraction. 2 times 9 is 18 plus 1 is 19. And keep everything here the same. Now I'm multiplying by 2/5 d, so I can divide both sides by 2/5. I can divide by the same number that I'm multiplying by. But I want to go with a different strategy on this one. I'm actually going to use the multiplication property equality, but I'm going to use another property that tells me reciprocals are two numbers that multiply together to get 1. They're also called multiplicative inverses. And the reciprocal, the number that I multiply 2/5 by to get 1 would be, I get that by inverting the 2 and the 5 and get 5 over 2. So this is multiplication and I can undo it with division, but it's going to be easier just to try to undo it with a multiplication. So if I multiply both sides by 5 over 2, parentheses there. This will be 1 because it's the definition of inverses. When you multiply them together, you get 1. 1d, which just says d. This would be 95 over 4. And you could leave it like that, but typically you would go ahead and see what is that going to be as a mixed number. And that would be 23 3/4. So either one of these is acceptable. Now I'm going to do one of the more complicated problems on page 99, number 16, which is m divided by negative 1.5 equals 1/2 plus 1. So I'm going to go back up to my steps, simplify both sides. This side, there's no arithmetic that we can do, it's done as far as we can go. But we can combine the 1/2 and the 1, and it would give us 1.5. And then change this to a mixed number, 3 over 2, and divided by negative 1.5 equals 3 over 2. So now I can decide whether I want to multiply by, I know what I should change this to, in the same step change this negative 1.5 to an improper fraction, It should be negative 3 over 2. The 2 times 1 plus 1, and the negative sign has to either go with the 3 or the 2, or it could go right outside the division bracket. It could be printed like that. I just put it up there with the 3. Either one of those 3 places doesn't matter. So I can either multiply by negative 3 over 2, or divide by 2 over negative 3. And I'm going to multiply by negative 3 over 2. And here's where you have to trust the system. If you multiply by negative 3 over 2, this is going to cancel. Use m on the left. And whatever I do to the left side, which was multiply by negative 3 over 2, I have to do the right side, which will give me negative 9 over 4, which is negative 2 and 1/4. I could leave it either way here. And this makes sense that if I divide negative 2 and 1/4 by negative 1.5, that tells me I'm going to get a positive number when I divide a negative by negative. And it makes sense that there's about 1.5, there's about 1.5 1.5s in 2 1/4. It's kind of a coincidence that it's the same number here. It's not any big deal, it's just coincidental. Okay, so that's a couple of examples on multiplication and division.